Far out into the heart of Lake Superior, the largest freshwater lake on Earth, a lone vessel holds position above the unknown. This is the research vessel Blue Heron, base camp for a groundbreaking scientific expedition. Beneath it lies Superior Shoal, a massive underwater mountain, nicknamed the Freshwater Everest. Rising nearly 300 meters from the depths of the world's largest freshwater conservation area, it may be as vital to freshwater life as seamounts are to life in the oceans. Yet its hidden cliffs and valleys have barely been explored until now. Today, for the first time, you'll join scientists and explorers on a live descent into this mysterious world. Using cutting-edge underwater drones, we'll search for gigantic and elusive fish, explore ancient volcanic formations, and ask a critical question. Is Superior Shoal a crucial refuge for freshwater life? And because this hidden shoal has long been one of the most dangerous places for Great Lakes shipping, there's even the chance of uncovering long-lost shipwrecks. This is real science, real exploration, and discoveries made here may shape the future of freshwater conservation. Welcome aboard the Blue Heron, and welcome to Exploring the Freshwater Everest, live from Superior Shoal. Welcome to the middle of Lake Superior, the largest freshwater lake in the world. And thanks for joining us for our first ever live stream dive. I'm Zach Melnick, a filmmaker and fellow with the Royal Canadian Geographical Society. I'm also an underwater drone or ROV pilot. My partner Yvonne and I have spent hundreds of days filming freshwater environments. Why freshwater? Well, we've all seen amazing ocean images on our screens, and most of us know that the oceans are in trouble. But few people know that freshwater ecosystems are actually far more imperiled than ocean ones. So our mission is to share with you how amazing the freshwater world can be and why it's worth protecting. Today, we're going to take you on an extraordinary dive of discovery, down from the top of what's probably the largest underwater mountain in the freshwater world, the Superior Shoal. This is a pretty special mission because the Superior Shoal is so remote. It's about 70 kilometers from the nearest shore, right in the middle of Lake Superior. Although it's rarely been explored by humans, scientists think this mountain and others like it may be important oases for freshwater life, just like seamounts are for marine life in the oceans. There's a number of species that we might encounter here that have never been captured on camera before, and there's others that are extraordinarily adapted to this offshore mountain ecosystem. And because the mountain rises to just a few meters below the surface, Superior Shoal has long been very dangerous for Great Lakes shipping. So we'll be keeping a close eye out for any signs of undiscovered shipwrecks. We want to give a huge shout out to our partners, Science North, Canadian Geographic, and Parks Canada, because Superior Shoal is inside the Lake Superior National Marine Conservation Area. Of course, we are not alone in this. We're part of a 9-day scientific expedition aboard the research vessel Blue Heron. And Michael Rennie here from Lakehead University is leading the expedition. And he's going to tell us a little bit more about what we're doing out here and why it's important.
Thanks, Zach. Yeah, so a lot of what we're trying to understand on Superior Shoals is how physical processes like currents, waves, and light penetration interact with the biological community and how that might be involved in supporting the biological community that exists here. And so some of those physical processes involve upwelling, as well as the deposition of material from the water column through back eddies and currents that go over the shoals. And all of those processes, as well as production of algae at the top of the shoals, which doesn't exist in the open water. And we're trying to understand how each of those processes impacts the biodiversity and abundance of fish that we see on the shoals.
Okay. So when we first heard about this mission, we were super excited. We basically begged Mike to let us come aboard. So we're kind of stowaways. But thanks so much, Mike, for giving us this opportunity. We're so excited to see this environment and to share it with everyone. We're almost ready to begin, but we're going to flip to the deck right now and introduce you to Yvonne, who's going to be managing the deployment of the ROV, and she's going to tell you a little bit more about the technology we're going to be using today.
Hey everyone, I'm Yvonne. I'm also a fellow of the Royal Canadian Geographical Society, and Zach and I are a husband and wife team. But of course, I'm out here on the deck doing all the hard work and heavy lifting. Anyways, this is our robot, our ROV here. It's about 60 pounds. It's a boxfish Luna. Shout out to the boxfish team down in Auckland who are watching with us. And we've named our ROV Kai after one of the rare fishes we hope to see on the shoals here. And our robot can go about 500 meters or 1,500 feet in depth, and it has 8 thrusters. And that allows us to swim in any direction, just like a fish would. It's got an acrylic dome on front that can really handle that intense pressure as we get deeper, and it also corrects the optics underwater. Inside the robot, we've got a really sensitive, super low light camera, the same kind of camera you'd use to film animals in the moonlight. And that helps us see as deep as possible without the addition of artificial light, so hopefully we're seeing natural behaviors from our fishes. And of course, you can't send a signal through the water the same way you can through the air with an aerial drone, so our robot's always tethered. We've got a fiber optic tether here, the same thing that brings internet into your house, if you're lucky, and the robot is always attached to back to us, and then this tether connects us all the way down to Zach in the bottom of the boat. I'm out here managing the tether, and Zach's controlling it on the control station down in the hall. Back to you, Zach.
That's right. I control the robot with this computer, and it's kind of like a video game. So there are multiple cameras, so we can see what's in front of and behind the ROV, as well as the main cinema-grade camera right here in the middle. Several of these other screens are dedicated to helping us understand where the robot is and what's around it. So this is a type of underwater GPS, so we can see where the robot is in relation to the boat. And this is a sonar that shows us what's happening up to 120 meters in front of the robot. With this tablet, I'm able to control all the aspects of the camera that you can control when you have it in your hand. So this looks like a lot of screens, and it is, but after using it for a couple hundred days, it kind of becomes second nature. So with today's dive, what we're planning to do is start in the shallows and hope to see some unique lake trout. So these are the top predators in this lake, and there are rare types of lake trout like the redfin and the humper that have evolved to live on these underwater mountains. And then we're going to descend into the deepwater abyss around the edge of the mountain, and hopefully we can see some deepwater species that are very rare to see on camera, like the biggest lake trout of them all, the siscowette, and maybe even species like the kai and the bloater, 2 very important Great Lakes species which, believe it or not, have never been filmed alive in nature before. So we're super excited because we really don't know what we're going to see down here, but that's part of why this is so fun. So how are things looking on the deck, Yvonne?
We're about ready to launch here, Zach.
Alrighty, so I guess I better get ready too. Okay, I think stuff is looking good on my end, so let's rock and roll here then.
Okay. Perfect. All right. Yep, got it. Thanks. Okay. Maybe give a thumbs up. Go ahead, Bianca, or Zach. Tell Zach you can go.
All right. So I am starting motors.
Okay. We're really lucky to have with us today one of our key collaborators on this project, Dr. Bianca Passamai. She was one of the leads on the paper that we published about proposing some of the hypotheses of what's going on Superior Shoals here, and she's actually going to be running the Q&A for today. So for people that have questions, feel free to go ahead and ask, and we'll do our best to answer them. So the first question that came in was, what's the air temperature? It's actually pretty nice. I couldn't tell you offhand because I'm not standing next to a thermometer, but I was outside in a t-shirt. So I'm going to say, like, I don't know, 15, 17 degrees felt like, kind of. Yeah, Celsius. I'm going to do it in Celsius because we're in Canadian waters. So whatever that is in Fahrenheit. So, but anyway, yeah. Oh my God, have we ever? Yeah, like it's we've been surprisingly blessed by generally flat water and calm weather, which has been pretty amazing. So, yeah, it's been incredible out here. I don't think we could have asked for better weather, to be totally honest.
Okay, so I'm now seeing the bottom showing up on the sonar, so that it should come into view pretty quickly. Yeah, and there it is. So here's our first views of Superior Shoal. So we are, the boat is parked just off the top of one of the peaks of this mountain, but we are right now at about 28 meters, so 80 or 90 feet or so.
And at this particular location, I think it goes up as high as, what was it, 9 meters?
Yeah, that's correct. So just off to our left here, it does get up to about 9 meters. Okay, and so we're going to follow along the top of the ridge here and see what we can see. It's starting to become lake trout spawning time. So remember, there's nothing around this underwater mountain for many kilometers, and certain kind of lake trout love to spawn on big piles of rock, and this is the biggest of piles of rock. So I would be really interested to see what the lake trout are doing if we do come across them here.
I guess one thing I'll point out too is you can see, as we're sort of on this top part of the shoal, you can see what looks like a bit of like fuzz and grass growing on the rock there. That's all algae that actually plays, we think anyway, and one of the hypotheses that we're testing is the degree to which that plays an important role in supporting the food webs out here on the shoals. Okay, so we have a question from the viewers to ask whether we're hoping to see multiple forms of lake trout, and yeah, we definitely are. So the ones that we might likely see out here, so the ones we'd expect to see right at the top, sort of where we are now, are lean lake trout. Those are ones that you might catch, near shore, anywhere sort of on the Great Lakes. But there's many other unique forms that we only see in these shoal environments, and those would include humper lake trout, as well as redfins. And if we get really deep down, we might even see some siscowette lake trout. So we do have different morphologies of lake trout that we can see in these environments, and we're hoping to see a bunch of those different ones for sure.
And there's been a pretty big revelation just recently about the overall health of lake trout in Lake Superior, hasn't there, Mike? Do you want to tell us a little bit about this kind of good news story? Really?
Sure. I mean, yeah. So there was an announcement, I think, was it last year or earlier this year, from the Great Lakes Fishery Commission to say that, the lake trout population in Lake Superior, writ large, is generally considered to be recovered, which is pretty exciting. And some people might ask, recovered from what? Well, the entire Great Lakes fishery was really decimated back in the 1960s through a combination of two major stressors. One was overfishing at the time, but the straw that really broke the camel's back was the invasion of sea lamprey. And thanks to a coordinated binational effort that both governments spend several $1 million a year on, we've been able to get that lamprey population.
Mike. Yeah, we could get that lamprey population down, and then these these lake trout have really rebounded, and from what we know, especially the lean type of lake trout, which is the type that humans mostly have contact with, that they're doing just as well as before that collapse. So really, I mean, that is the large, like, these are the most important predator species in the largest freshwater lake on planet Earth that have been restored by humans. So that's right. Pretty cool, right?
Oh yeah, for sure. Sure. And
you see that I'm gonna do like a little switch here, but yeah, you can see how they're actually we find, so we've done a couple of pre-dives here, and the fish out here on the shoals seem to be quite friendly. And it could be because they just have so little contact with humans.
And I always find it hard to understand, how big do we think these fish are? From the video, it's hard to tell. How big do we think these guys could be?
Yeah, I mean, that's a good question. I think, well, I would say typically these things are coming in between sort of 40 to 60 centimeters typically is what we might see. For typically, of course, you'll get some small ones, some big ones, but, you know, on average, that's sort of, I think, at least at this part of the shoal, that's sort of where they would be coming in and around. Yeah.
All right.
So not small fish.
Not small, yeah. I mean, you know, anywhere from I guess what I'm say 800 grams or you know, just shy of 2 pounds, upwards of kilogram and a half, 2 kilos. So getting up into 4 or 5 pound territory.
Nice.
Yeah.
Oh, here's another one here, and this one seems to be feeding on the stuff that's been deposited on the rocks, and that's kind of part of this whole hypothesis, isn't it, Mike?
That's right. And I mean, some of this behaviors that we saw, I mean, on one of our pre-dives, looking at some of the behavior of these fish at night, especially with the red fins that have these very long fins compared to leans, they seem to get into some of that, fuzzy algae that grows on the sides and really sort of disturb it with their fins, and bugs and other things will swim up from the algae that's attached there. So it's this really interesting, thing to see. Oh, and this one's got sea lice on his tail. So those are copepods. And they're parasitic, and actually what you're seeing there are mostly the gonads of those copepods hanging off there. So, but anyway, yeah, sorry, just an interesting observation. We see those on Great Lakes fish fairly frequently, and they're reasonably benign. They don't seem to really hurt the fish too much.
So right now we're at 32 meters. So
yeah, so still quite shallow.
Still quite shallow, especially here for the shoals.
And I would say, based on sort of light penetration from some of the profiles that we've done in the area, you're still getting, you know, enough light down here. You're just starting to hit that point at where the light is running out, so that you can't support photosynthesis. But we're sort of still in that sweet zone for supporting algal growth. To feed all the other things.
Turn around and come back out from where we come back out of this canyon.
So can you say, sorry, Bianca, could you repeat that? Why? What are they eating if the lake is so clear? Was that the question? Yeah, so this is what's interesting about these environments. You're right. We're in the middle of the lake. There's like nothing going on really. So there's sort of two main food sources for organisms out here. One would be, even though it's really clear, the algae that grows in the water column. That algae gets filtered out by tiny organisms called zooplankton, which you can kind of see little dots jumping around in the frame. Those are the zooplankton in the water column. And then those are eaten by filter feeding fish, which then the lake trout can eat. So even though it's really clear, there's still some productivity out here that can support those fishes. The other really important source of food for these fish is on these lake mounts. We get these mats of algae that grow, especially in the shallow regions. And in those mats of algae, you get other things like fly larvae or side swimmers or amphipods, or the other thing that we see a lot out here of is the freshwater shrimp mysis. And we see those a lot on the shoals, especially at night when they kind of come up from the deep to feed, and they seem to be a really important sort of keystone species in the Great Lakes, especially for lake trout in terms of becoming a food source. So they can bring food from way, way down deep, 200, 300 meters deep in the lake, and bring it up to these shallow environments for fish to feed on.
And we might actually see some mysis as we get down deeper off the edge. I'm hoping to show you folks some mysis because they're a super cool freshwater shrimp. They make these massive migrations from super deep during the day up closer to the surface at night. So hopefully we can zoom in on those guys and show them to you here. But I'm just gonna keep moving through this canyon, and that's one of the things that's really interesting about this is that it's there's all these sort of undulating granite canyons that are in the sort of mid to close to the top of this mountain, and we're seeing the fish in these sort of canyon areas. So we'll just keep on moving.
Let's see if we can
along
see
here.
You got a couple. There you go.
Yeah, there's a couple there. Yeah.
What forms the mountain? Is that the question? So, okay, so another
that
question.
That one took a bite.
Yeah, that one's feeding, so there you go.
That one took a nice bite.
So what's so there's actually been some early geological studies on the rock formations of Superior Shoals that was actually done by a geology professor at the University of Toronto, Mississauga. And they were able to determine that a lot of this rock is volcanic in nature. But what's interesting is as we fly by and you can see sort of what the rock looks like, you can see how that rock, even though it started out as sort of volcanic originally, it's been carved out by glaciers that occupied this area, 10,000 years ago or so. And just the scour that happened from those glaciers moving past is what's really formed some of these canyons and trenches through this otherwise, very large volcanic structure that's here in the depths.
So Mike, tell me a little bit about what we think might be going on here. So we have two fish, and there's a little bit of something going on here. Any thoughts there?
Yeah, so you see one bigger fish and one slightly smaller fish. The bigger one looks like it's a little more rotund. If I had to guess, I would say that's probably a female. The males often tend to kind of hang around the females in pre-spawning periods, and they'll be sort of sniffing around, trying to assess the status of the female, whether she's getting ready to release her eggs or not. This is a unique situation where we only see maybe one male hanging out with a female. You often might encounter situations where you might have 5 or 6, particularly as those females get more and more ready to spawn. But in terms of temperature, we're really kind of in that sweet spot for temperature. I think it's not unreasonable to think that we might have some fish that are getting very close to spawning this time of year, particularly on the Great Lakes. Where I do a lot of my work at the Experimental Lakes area, that typically doesn't happen until about middle of October. In these unique environments, the spawning status of these fish can be a little bit different.
He actually tried to shake there a little bit.
Yeah, looks like it.
So she's not ready, but
he sure is.
he sure is, because that's what they do when they actually release their gametes, as they call them in fish land.
What is the temperature down there, Zach?
See, there's some actual shaking going on, and so that's the male trying to get the female basically
trying
excited
to stimulate
and
the female
trying to release her eggs, right?
That's right. Yeah.
How warm is it down there?
The temperature where the ROV is 6.25 degrees Celsius.
Mm-hmm.
And we know this because we recently installed the temperature logger on the thanks to the boxfish people. Let me throw on the lasers so we can get a sense of the size. How the size of these guys. Oh, actually, the other fun thing that's happening is the fish is chasing the laser, right? you heard about, it's just like a cat.
Yeah.
But
the cats of the underwater world. There you go.
Yeah. So they're like, oh, what is that? And what is
So that the spacing between those lasers is what, 10
10
centimeters?
centimeters. Yeah.
So that fish is going to be, somewhere in that sort of 40 to 50 centimeter range for sure. Yeah.
So a big fish. That's a big fish.
Yeah. It's
medium-sized fish.
Good
There,
size.
well, let's see if we can find a bigger. All right, let's leave this couple here, just in case
give them
there's-
some privacy.
Give them a bit of privacy.
There you
Yeah.
go.
Maybe we'll catch up with them on our way back, shall we? All right. So I'm going to continue our way down this canyon here.
So we have a question in the chat about whether we see any sign of coaga mussels, and I would say thankfully no. We have seen evidence of the cousin of the coaga mussel, the zebra mussel, coming in a couple of spots in Lake Superior. We do tend to find them in Nipigon Bay on the Canadian side. We see them in and around the Apostle Islands on the U.S. side, and we know there's historical accounts both in Duluth Harbor and in Thunder Bay Harbor. But thankfully, we have not seen coagas here yet. And I don't, they're everywhere else in the Great Lakes. But we're lucky that we haven't seen them here. And I think a large part of that is because we have very, very soft water in Lake Superior. So there's not a lot of calcium, which is a good thing because those mussels really need that calcium to build their shells. And so with a lack of that calcium, that means that I think that's playing a large role in keeping them out of Lake Superior. So thankfully, no, but it's definitely something that we're keeping our eye on. We're also, in addition to this ROV work, we're sending down samplers to look at what the benthic communities look like. So what kind of bugs are living on the floor of the lake. And that's another good way to survey and see what kinds of, whether or not we have mussels in the system. And thankfully, we can say that we haven't seen those yet.
Okay, so the depth right now, we're at about 31 meters still.
Oh, there's another fish.
Yeah, there's another fish here, and we're looking for different forms of lake trout. We mentioned there's different types, so these aren't different species per se, but they look a lot different.
Different body shapes, longer versus shorter fins, even some different coloration, different body shapes. We often see that, yeah.
So we
and very distinct, all living in the same environment. So, oh wow, look at that guy. That's great.
The water clarity is, my guess is it's about maybe 15 meters right now. I would say it was maybe 10 to 15. It was a little bit better a couple of days ago. We've been out here on the shoals now since Tuesday night, or we left
Wednesday morning last week.
So we'd been out here for a few days, and the wind direction changed, so we think that blew a bit more matter into the water here.
And the currents have changed too. That's the other interesting thing here. Like, we've been in situations since being out here where the wind is blowing one direction and the currents are pushing in us in another direction, to the extent that we're actually the boat is getting pushed into the wind. The currents are that strong. So, which is something that I was surprised about. We've got instruments out recording data to help us understand the direction and the magnitude of those currents. So that'll be really interesting to get back and look at once we get back to port and start to download our data.
This is something a little bit interesting here. So even though we're 33 meters down there, it looks like wave action is creating these divots in these waves of sediment here. So that means that when the waves of Lake Superior get roaring, the gales of November, when they get roaring, that they can have an effect this deep.
It's not uncommon to see, if you look at buoy data, to see often in November like up to 30 foot or 10 meter swells. out here, which is like, yeah, thank goodness that's not what we're encountering. So, or we wouldn't be here.
Yeah, yeah. Well, we've had spectacular weather, as you say. It was completely calm yesterday, and it's nearly that today. So you don't have to worry, Mom. We're safe out here.
That's right. Okay, so question from the chat: have we mapped this terrain? And we have not. There have been efforts in the past by other researchers to get sort of a more detailed topography or sort of shape of what things look like out here. That would be something that would be great to try and sort of get all. This is, different people get different parts at different points in time. So I think it would be really good to try and get people to bring all that data together in one effort, or even just get out here with sort of a multi-beam sonar and get a really, really good handle on how complex the topography is here. We have a little bit of that from some of the hydroacoustics work. So basically driving around with very expensive fish finders at night. And we've got a fairly good picture of what some of that relief looks like. But that certainly is something where if I had that in the planning of this trip, would have been super helpful initially. But so it exists in bits and pieces, but we really require the effort as a community to pull all that information together and get that together so everyone can use it. So how deep are we here, Zach?
Now we're 35.
Okay.
35 meters. Yeah, I'm thinking about starting to go deeper, but I was just trying to go over this ledge here just to get one more sense of see if we can't see another form of lake trout here.
Sure.
But I wouldn't be surprised if when we went a little bit deeper, we might be able to see.
Is that something?
So we are looking for any signs. So there's a question about are we looking for shipwrecks? Well, we are. So just because we always are when we're in the Great Lakes and down here, we're primarily sort of specialist in biology in fish, but we have been hearing these stories about the ships that have gotten lost in Lake Superior, and the Superior Shoal is one of those areas that people often talk about as being a prime candidate for maybe where some of those ships disappeared. In particular, there's two French minesweepers that went down, I think in 1918, right at the end of the First World War, and it was a huge loss of life. I think 120 sailors or so. Both of them went down in this storm, and there's some idea that they may have foundered on the shoal here. So we haven't seen any sign of shipwrecks yet. We're also on the lookout for any other anthropogenic or human stuff that we see, because long ago this mountain would have popped above the surface as an island, and so it's conceivable that people could have made it out here at one point long ago with large canoes and whatnot. So we're also keeping our eyes open for that kind of evidence.
We're kind of acting as a floating island ourselves right now. We seem to be collecting migrating birds as they make their way south, and there's a whole bunch of them with me here on deck, so lots of entertainment that way, but lots of little warblers and sparrows and nuthatches. So it's not just fish out here. We've got birds too.
The whole gamut.
Yeah, the camera, so with this robot, we can put different lenses on it. And so Zach currently has a zoom lens on there right now. To see super, super deep, we usually use a prime lens, a fixed lens that allows us to get more light in the camera. But right now we've got a zoom lens on so we can zoom in there and see what those lake trout are eating.
That's right. I have a 20 to 70 millimeter lens in there right now. And so we can get a pretty good close-up shot there with that, which we'll hope to show you as we go off the edge of the mountain and get going down deep. So what I'm going to do now is I'm just going to head where we went about 120 meters or so away from the ship. So I'm just going to head part of the way back, and then we'll try to descend down the rock face here into the depths. But we'll probably see a couple other lake trout on our way back.
That's as far as Zach can go, but we always like to give ourselves a little bit of slack at the end, so we're not too worried about it.
This topography as well, with all these undulating slabs of granite in here, it's possible to get the tether snagged as well. So we just got to be careful. And if that happens, don't panic. We've been there before. We'll deal with that if it happens.
The tether does generally float, though, in fresh water.
Correct. Yeah.
Or it's close to neutrally buoyant, but
at least this one does. They haven't. Oh yeah, there's another trout there.
I will say one of the things that we did some test dives as well at night so far too. That seems to also influence some of the different species we see. So definitely encountered a freshwater cod or a burbot when we were doing some night dives. So there's certainly diversity out here too, more so than just the lake trout. But this is really important structure for them, and certainly during both times, day and night, seems to be really, really critical habitat for that species.
Yep. So the question is, how do I know how much tether to be letting out or pulling in? So I've got a little monitor here on deck, so I'm watching the ROV feed all the time. And then we always wear headsets so we can talk to each other. Zach can tell me, hey, I'm coming back, hey, I'm going out, pull in, let some out. But because it's a fiber optic tether, it's really delicate. So I need to be really mindful about not putting knots in it. We have broken it before. It's not great. And when you break a piece of fiber optic, you can't splice it. So you have to cut the tether where it's been broken. So then we lose all of the piece that's between us, the break and the robot. So we just need to be super careful about the tether and how it's going out the boat, how hard we're pulling on it. If necessary, though, if something goes really awry, I can pull the robot back in with it. It's got a Kevlar coating on it, but we try not to do that as much as possible.
And we have done field repairs on the tether too, but it's not a lot of fun. So now we have a backup tether, which makes more sense.
Yes, so there's actually 3 cameras on the robot. There's the main camera with the great low light capability and that we can change lenses on, but there's also a front-facing camera and a rear-facing camera that are kind of like a fisheye camera. So they're super wide, so they give us some navigational awareness. Often when we're swimming around in the Great Lakes, we tend to collect things like smallmouth bass behind us, so we can see fish sneaking up on us, and we can turn around to get a shot with a really great camera.
But there's no smallmouth bass out here in the middle of Lake Superior.
Yeah, so good question in the chat. What other species are we expecting to find out here? So we'd love to see some whitefish. We do know that they are in the region. So lake whitefish is one. There are several species of siscos or lake herring that we might encounter. Certainly as we go deeper, the bloater and the kai would both be forms that would be really exciting to see, or species, sorry. Lake herring tend to be more in the open water region, so we might not encounter them right on the shoals like this, but but certainly lake whitefish, freshwater cod or ling cod or burbot. We might expect to see these out here. Various species of sculpin, deepwater sculpin, which would only really be sort of deep down in deeper waters, and those are actually a threatened species in Canada. So those would be exciting to see. Yeah, so certainly more than just lake trout, but that seems to be kind of what we're seeing most of today anyway. So, but we're on the look for everything. We're on the lookout for everything.
Another interesting thing that's happening that I'm actually grappling with right now is that there are magnetic anomalies on these on this mountain. So that makes navigating a little bit more challenging because north ain't north at the moment. So I'm gonna talk with Yvonne for a second here to try to get a sense of.
You were coming in there.
It was coming in, but now it feels like I'm not.
You're going out.
Okay.
Yep.
So I think I'm gonna. It's not gonna be too exciting, but I need to do the old school method here and try to find and follow the tether, because as I say, north ain't north, and our map here is basically correct, but
the compass is not.
The compass is not. So.
Okay, great question from the chat. So there's a question about whether the lake trout that we see on the shoal are just on the shoal, or do they migrate? And I think that's one of the questions that we're really trying to address, not broadly, but not just as part of this mission. So we've put out some acoustic receivers for Parks Canada, and those are now in and around the shoals, so that if we do get fish that have been tagged elsewhere migrating out here, we'll be able to see those tagged fish on those receivers to help try and answer that question. The other interesting thing about the shoal environment is that when we were talking about the lake trout having been deemed as recovered in Lake Superior, a large part of that recovery was through we got another fish here too, was through stocking, and a lot of that stocking was done in nearshore environments. While one environment that was never stocked that still seems to have a lot of lake trout is Superior Shoals. So there's a really legitimate and open-ended question as the degree to which these kinds of environments can act as kind of like rescue populations for other areas of the Great Lakes. If fish are migrating from the shoals to other areas, could they be involved in helping recover those more stressed populations? So we're actually we're going to do some fishing for lake trout and collect non-lethally some tissue samples, basically some tips of fins that we can send to a lab with the Ontario Ministry of Natural Resources to try and look at the genetics of these fish and see how different or how closely they match other populations in and around Lake Superior, to try and answer that question. So that's a really good question, and something that we're actually trying to evaluate here on this mission.
So we're still around the 32 meter mark, and we'll go as so it gets down to about 250 meters or so around the edge of the mountain. We probably won't get there, or actually down to 300, depending on the side of the mountain. But hopefully we'll get down to 80, 90, 100 or more here. So Yvonne, I'm just going to need a little more of a hand here in order to...
so going out now.
Still going out? Okay.
You were coming in until very recently.
Okay.
Coming in a bit more now. Yep, pulling in now.
What was the question about age again, Bianca? is there a way to determine age for the fish that we catch? Is that the question that we have? Yeah. So non-lethally. Yeah. So yes. So there we have done some exploratory fishing for one night already. We're going to continue with that
Coming in soon.
in the next couple of nights. What we're doing to collect these fish is we're setting our nets very shallow and only for very short amounts of time. So we're able to release most of those fish back into the lake, and they recover quite happily. What we are taking to try and get some age determination, it's not exact using this method, but we'll take a couple of fin rays from the pectoral fin. We can cross-section that. We can mount it in epoxy and cut that into cross-sections and look at the annular rings on those fin rays to give us a sense of age. It's not as exact as other structures that you can take, but all those other structures require you to kill the fish, and we're doing our best to make sure that we don't want to harm a lot of fish in our survey out here this time around. So yeah. And what was the and there was a second question, I believe, too, right, Bianca? Do they grow more slowly in deeper waters? Well, one thing that we do know about lake trout generally is that when you look at lake trout that are from more northern environments, they tend to grow more slowly, but they end up getting bigger through their lifetime. So those two things, sort of between body size and growth rate, seem to trade off. So at deeper waters, Jesus, good question. I think, we do see forms of lake trout that are highly adapted to living in those deep water, cold environments, the siscowette. And I'm going to say I would need to go back and look at some papers to make sure I know what I'm talking about there. But I would say that broadly and sort of across a latitudinal gradient, if you were to look at fish from, say, Great Slave Lake up in the Northwest Territories compared to ones that we would find here in the Great Lakes, the ones in the Great Lakes would tend to grow a little quicker, but the real lunkers, the large body sizes that you see on average would be greater in those more northern environments. That's not to say we don't get very big fish here in the Great Lakes as well, but it just takes some they're just, you don't see them as frequently as you would in the north.
Still bringing in.
Okay. So I think we're starting to get reasonably close to where we can dive down here, and we'll see how deep we can get to. So we are expecting a pretty precipitous drop off here at some point in the near future.
So the question in the chat as to why we get these magnetic anomalies on the shoal. So it's a good question. So this paper that was written on sort of describing the geology of the shoals back in the early 1990s, which is crazy actually. The paper describes them packing into this tiny little sub and floating down to collect rock samples and all sorts of other stuff, which sounds horribly uncomfortable in talking to the prof that did it. But anyway, if there's any iron at all in these rocks, which it sounds like there is, that can really throw your compass off. And they can actually, in that paper, they can use sort of the magnetic properties of the rock and the sort of orientation, quote unquote, of the actual rocks and the magnetic orientation of those rocks to tell you something about the volcanic history of these rocks as well. So it's mostly because we're around a rock face that's rich in iron deposits that's causing issues with our compass. Is it part of the Canadian? Yeah, so the question on the chat is, are the rocks part of the Canadian Shield? So we
Oh, okay, so...
Is that your tether?
Sorry, that's not our tether. That is actually the boat anchor.
Oh, it
So,
is. So you want to get on the right side of that.
We want to get on the right side of that. The question is, what is the right side of that? But you can see that there's some pretty good drop off on this mountain. But I do not want to get tangled in that.
Can you see your tether?
Don't get tangled in that. So so I can see from the so we've actually accidentally gone past the boat, I think, is what has happened there. So
I think there's a big wow in the tether because it's still going out the back of the boat.
I see. Yeah. Okay. So we are going to try and
maybe just follow that
get
to
out
the
of
back
this
of
pickle here, which is going to unfortunately require me to
Backtrack.
have not a very exciting backtracking on the tether here.
Well, while Zach does some backtracking, we'll try and get back to that question about the Canadian Shield. So, that's a good question. I am not a geologist. I am very much in the biology world. So I would probably have to talk to my old geology colleague from University of Toronto there to better answer that question. What I would say is that we know that a lot of the Canadian Shield lakes are sort of like metamorphic in nature, right? And it extends down into the Lake Superior region. So whether this particular formation would be classified as shield or not, I'm not gonna jump out on a limb and say whether that's the case or not. But we certainly are in the shield. The transition, if you're in Ontario, the transition from shield to sort of more limestone and that sort of stuff occurs right around Lake Simcoe. And then it's really kind of shield from there up, extending right up into the Northwest Territories. On the mission, yeah. Okay, so the question is, what kind and how many scientists are on the mission? So on the research vessel Blue Heron, we have 6 berths or places for scientists to be able to go out on a mission. So there's myself. I'm the chief scientist on the mission for this particular cruise, and then I've got Dr. Bianca Possami from the University of Vermont.
You're right at the back now, Zach.
And she is she's one of our key collaborators. She was the lead author on the paper that we put together to try and understand, sort of like summarize some of the hypotheses that we're testing out here for why these offshore regions are so productive and have such high biodiversity. And then we've also got a superstar student who's going to be starting their graduate work at University of Vermont, Gwen Phillips. She's with us as well today, and Lydia Pollock, who is a technician with the Rayon project at the University of Windsor, who is our glider pilot. So we have another instrument that's sort of doing a big circumnavigation of the shoals, collecting data there. And then Zach and Yvonne as well out here, who we are putting to work as scientists as well. It's not they get to do all the fun ROV stuff, but there's a lot of water filtering and zooplankton collection and stuff that's also happening when they're not collecting ROVs. So
Yvonne,
Yep.
just so there's a bit of a I'm sort of wrapped around the tether here. So before I
Yeah.
go deep, I just need to get that unwrapped. So
All right.
is there any
I'm coming down.
any thoughts about how?
Come on down to me.
Well, I mean, might be able to do it as well if I have instructions about. Well, I guess you're right there. So,
yeah.
so you guys are getting a look at how we we get an early look at the bottom of the Blue Heron here. But Yvonne is just going to try to untangle us in the tether here.
Okay.
Sure, yeah. So there's a question about whether we're doing any acoustics for fish. And so one of the things that we can use for monitoring the abundance of fish is through the use of hydroacoustics,
nope.
and so those
You're
are.
s-
Oh,
Sorry,
sorry.
Zach,
We just
you're-
we're just trying to sort something out
Zach,
here.
you're
Yep.
still just wrapped up.
yeah,
So if
and,
you turn to your left,
Yep.
if you spin around to your left. Oh, it's caught on the DVL. I see what's happening. Okay, can you come back to me? If you just hit reverse right
Reverse,
now, you'll
yeah.
come back right into my hand. Can you?
Okay, so we're suspended. The motors are suspended. I'm not sure if you can hear me, but
Yep, I've got you out of the water here, and I can
Oh,
put you
she's
right
got
back
you.
in. Okay.
yeah, we're okay. But we need to. The motors are suspended, right? So we need to go back. I need to get you to hold it again.
Yep. Okay, go ahead.
We're wearing comm systems, but right when Yvonne is deploying the ROV, literally hanging off the back of the boat, the comms go away. So
There we go.
looks like we
Yep,
did
it had just got caught on the DVL.
So we're all good.
we're all good
Yep, all
again. Yep.
good.
So we're
Alright.
now gonna try to we're gonna go down deep, folks.
Okay. So we've got, well, what, 4 different instruments that we've got out to use sound, basically, to understand the abundance and distribution of fish on the shoals. So the one thing we've been doing is I've been staying up on deck every night for the past several nights.
It's true. Poor Mike has barely been to bed, so he's doing remarkably well,
Well,
as a science commentator
that's
for
right.
having not slept for the past 4 nights. but-
It's all for the sake of science here. So we're doing surveys at night with our very expensive and sensitive fish finders, and so we're doing transects over the shoals at night to look at the densities of fish and where they seem to be concentrated, whether they're on sort of the upcurrent or downcurrent sides, and whether that is different is one of the main hypotheses that we're testing. We also have 2 stationary units that are sitting in the water column on shoal surfaces, both on the north ridge and on the south ridge, that are stationary and up-looking to try and understand whether or not we see differences in the densities of fish in those 2 areas. And then the last thing we have is on our glider, which is a how do I describe what this is? This is like basically an underwater sub that will go down to just about the bottom and then come right back up. And on that, one of the payloads that we have on that glider is an AZFP, which will collect data at 3 different frequencies that will also tell us about fish densities.
Sorry there, Mike.
That's
Just
okay.
1 second. So Yvonne, what is the direction directly out the back of the boat from your understanding?
Just checking my compass. North.
Okay. Thank you.
We're good?
Continue banter.
All right. Okay. So
These magnetic anomalies, oh man.
So we've got just about everything under the sun that we can use to use sound to try and measure fish abundance that we possibly can. So we got to pick a bunch of that stuff up in the next couple of days before we head back to port. But the good news is at the end of this mission, we should have a really, really good sense of what the distributions of fish are around these shoals and how that corresponds to a lot of the other data that we're collecting on currents, on distributions of algae and that sort of stuff, as well as information that we're collecting on chemical tracers. So when we're doing those non-lethal samples for aging structures on fish, we're also going to use some of that tissue to use a chemical tracer to tell us whether or not they're relying on energy that is grown from that algae on the shoals versus just floating around in the open water there. That looks like your anchor again.
That looks like our anchor again. So that's
Just go the other direction.
Yeah, the tether seems to be taken right out the back by the current, so that's interesting. You're seeing the anchor.
okay. So we need to find our way off of the top of this shoal here. So we need to consider where the anchor is and devise a direction to get ourselves down deep. So
okay, we've got one of our key collaborators, John Jansen, in the chat, asking about some of the glacial scars. Geez, okay. Really pushing my knowledge here, John, but what can I say? I guess I would say, like, what I can say is that a lot, and maybe we can wait until we see some, but there are definitely areas on these shoals where you can see scouring and scarring from essentially like massive chunks of ice that are dragging this stuff around. So and cutting out big chunks of the rock when those ice sheets
we
move
get the
through
captain
here,
to zoom out the
several 10,000 years ago kind of thing, when this was all just basically a block of ice prior to it melting and forming Lake Agassiz. I guess that'd be what, 20,000 years ago is a block of ice. So yeah. But thanks, John. Appreciate the question.
Are there lake mounts in other lakes, Mike?
Are there lake mounts in other lakes? Yeah, there certainly are. So one of the ones that's getting a lot of attention recently is the one that that Bianca has spent a lot of time considering, which is out on Lake Champlain, on the shores of where she works at the University of Vermont. So they've got it's smaller scale, but it's as sudden in sort of elevation as Superior Shoals is out here in parts of the shoals. So that's pretty cool. We also see these kinds of environments in other systems too. So there are large underwater shoals in Lake Michigan that are used for spawning by lake trout. And in other regions too, and we there's plenty of other large lakes in other parts of the world, like in Africa and in Russia, like Lake Baikal, where I don't know that we necessarily have the information on the bathymetry of those systems to ask whether those systems have these kinds of environments as well. So but I think what we can see is, based on the work that we've done to see how these things operate in ocean environments, like seamounts, as well as some of the consistencies that we see in lake mounts between what we're looking at here in Lake Superior as well as in Lake Champlain, we can start to build some ideas around how these environments might play a similarly important role in other lakes where they can exist as well.
So now we're at 47 meters. So we're starting to descend here, and I expect to have a bit of another bit of a drop off here. And
haha. Okay, question in the chat was, is Isle Royale considered a lake mount? That's a great question. So I think for the purposes of how we've defined them, the answer would be no, largely because it breaks the surface. And so there are all these interesting things that can happen when you don't actually break the surface, because now you have an opportunity for water to pass over top of the shoal, which can create back eddies from those currents on the other side. Now, that's not to say that you can't have similar processes happening on...
Oh, there was a small fish that just jumped out. And also, there's a very much of a different... we've had a geological thing happening here. Looks much more mountainous. Looks like it's sort of talus that we've just went down here. Yeah. But yeah, we might have scared a little. There was a little fish, and now we're at 60 meters right now. So we are indeed descending. I'll have to turn on lights pretty soon. Yeah. In order to, but yeah, I wonder if that's a fish up there.
Oh yeah,
in the distance there.
Yeah. I would say just on the
Oh,
basis.
actually, there's a bunch of fish
Oh,
there.
yeah, right there.
But you know what? Question is, did I get the tether snagged in these?
Are you stuck?
Doesn't feel like it.
No. Okay. Okay. No. Yeah. So there are a bunch of fish here, right at the end of our ability to see in the darkness here. We're gonna have to turn on some lights here because we're at 62 meters. So yeah, I'm gonna have to turn on some lights, and we're gonna make some camera adjustments, and then it becomes.
What's all that stuff in the water?
Yeah, what is all that stuff? That's all plankton. So these are the things that, and you can see them sort of bouncing around in there. Those will be things like copepods and other organisms that particularly planktivorous fish like cisco will feed on, and some of those deep water forms of bloater and kai and that sort of stuff. Just to come back to that last question real quick, I would say I think some really interesting work to do would be to look at sort of how some of those island environments like Ile Royale or the Slate Islands, where you get sort of, they're a landmass that comes out from very deep surroundings, how those kinds of environments compare to these lake mounts. I think that's certainly something that I don't know that we have the answer to right now. That's a great question though. So the question is the shoal protective for baby lake trout or eggs? And I would say the answer is yes. Like there's a lot of evidence that fish out here are using this area for spawning. And so, but because there's such intense wave action out here.
Here we got what do we got here?
I don't know.
Let's see how they're gonna react here.
There you go. Yeah.
Yeah, here's a little.
That's a laker.
It's a laker, yeah. And I wonder what that may be a siscowette with the big eyes like that, or a humper maybe. Oh, there's another one there. Yeah, so they appear to be a little bit attracted to the lights here. Kind of bouncing off a little bit.
If I had to place a bet, the one that we just ran into, I think I'd probably say he's a little closer to the lean morph. But I don't know. I'm sure I've probably got some colleague on the chat who's going to correct me. But anyway,
it's true.
That's
I just
fine.
did. That one has big eyes, so I was just wondering.
Siscowette.
Okay. Well, you know.
I guess that's the voting. We will.
Mike's primarily
primarily
a limnologist, right? So you know.
Well, or a lot of the work that I've done is in inland lakes, and I haven't done a whole lot of work on these sort of offshore environments. So yeah, I'm learning a lot here too, which is great. Cause
that was just a bit of a dig.
Yeah. Yeah.
So this is also interesting. So very feels very volcanic. These rock formations here. Feels very mountainous. I'm at 77 meters right now, so you get a little bit of, if I look up a little bit, you see the little bit of light in the sky there. But other than that, it's
pretty dark.
Pretty dark at this point. And it's interesting to note that
we got some mices too. I think, so if you can see them. Anyway,
on the ground or
they were just in the water
air,
column.
Yeah. If we can find some on the ground, we probably, I don't imagine that the detail on the stream might be quite enough to
really see what they look like.
To see them, but maybe looks like I might have bounced off the wall a little bit there. But yeah, so this is feeling
some battle scars.
Feeling deep now, yeah, a couple battle scars. Feeling deep, so we're at 80 meters right now.
Wow. So
we're getting down there, and it just feels like we're going down the side of a mountain right now. You know, and it had this sort of rounded tops, but now this is much more jagged sort of environment. We're at 82 meters, and I wonder, I'm just wondering if we come a little closer to the ground here, if there's anything interesting that we can
like
see. I don't think see if we any mysis or anything like that. kind of punch in. Not right there. So let's keep going. How are we doing with tether there, Yvonne?
We have lots of it. It is kind of going under the boat a bit.
Okay.
It
Well,
is
we'll
going
deal
under
with
the boat a bit, but I think
we'll
it's-
deal with that when we
think
come
it'll be
up.
all
So I'm
right
going to follow
based on what's
when we
happening.
come back. We'll follow our exact same path. Basically, follow our tether back. But I don't want to go. Well, we'll see. It's a very certainly is an interesting, very mountainous type environment. I keep expecting to see something around every corner here. Now,
So question on the chat on how the light affects fish behavior. That's a good question. I would say, I mean, we've done some underwater ROV work on our inland lakes out at the experimental lakes area. And I would say, well, Zach would may have a different answer, but in the work that we've done, they really don't seem to be terribly bothered by it. And that includes everything from things like yellow perch to sculpins to lake trout. Even though you're flying by with these bright lights, they don't seem all that bothered by it. What do you think, Zach? Like, what's your experience been?
I would say it totally depends on the individual fish and the personality of the individual fish, and it also depends on what they're doing, and it depends on how big of a group that they're in.
What's
we
that?
got a piece of wood there.
Is it?
Ooh.
We do have a piece of wood there.
Weird.
I don't know, our archaeologist friends will probably be interested in this, so I am recording on this right now. So it's pretty far out here for there to be wood without any kind of reason.
I have been told by a marine archaeologist friend that, wood that you just find on the bottom of the lake sometimes can be, 5,000-7,000 years old. So
Interesting.
you really don't know until you take a sample of that wood.
Yeah.
Maybe I'll just mark that. I'm going to mark this location. I'm still getting a USBL connection, so that's
Wow.
fairly remarkable. So
nice.
that must be that we're positioned the boat really well. But yeah, I'm going to make a mark on that because we have people that might be interested in that. It's very strange to have a piece of wood.
Not a lot of wood 70 kilometers offshore in Lake Superior.
No, and we are so now we're at 92 meters.
Wow.
And I don't want to go too much further because it's such a sort of a dangerous environment as far as the tether goes, because it could get potentially snagged. Usually we go down much more gradual slopes. Oh, what do we got there? We got a little something or other.
That's a sculpin.
Okay, so we
That's a
have
sculpin for
a
sure.
deep water sculpin there. Let me get a good focus. Oh, let me try to get focus on them. Try to
There
get a
you go.
focus. Yeah.
And didn't you guys see, like, I can't even remember, in All Too Clear, don't you guys have a whole bunch of, like, weird little nests and stuff?
We
for
do.
these
We
guys?
have
Yeah.
actually filmed some of these guys nesting when we were in Lake Ontario. But so this is at 94 meters right now, and that
Nice.
is they're actually listed as a threatened species in Canada anyway.
Yeah.
But there they
Cool.
are. There they are. And
Hanging out.
Yeah, and they're especially adapted for the deep waters, right? In fact, they can't even they can't go up into the
No.
water column, right? They
No.
can just sort of hop along the bottom.
Yeah.
Oh, yeah, I've
Cool,
kicked
cool,
things up a little bit there. All right, well, let's see if we can, let's push it a little farther because we are. And then what is this stuff here? This, is this the stuff that's fallen off the,
Yeah, I mean, so this is one of the things that we're trying to sort out. If you have these big, very sudden drop-offs, there's a lot of opportunity for either stuff that was growing on the shoals or material that is just deposited on the bottom to accumulate on sort of the leeward or down current side of these shoals. And the degree to which that material and the recycling of that material, either from consumption by benthic organisms or through the release of nutrients back into the water column, how important that is in fueling the abundance and diversity around these regions. So yeah, it's kind of interesting to see, just from what you blew up with the jets there.
yeah.
That's all like clearly biological material. So, and really sort of focused on that big end of the slope.
This is
right?
actually this is an intense slope. So this is I've been pointing about 50 degrees down this whole time.
So a lot of accumulation right on the face of that.
Yeah, so that's potentially important info for the work we're all doing out here, right?
Sure, sure. Too bad we don't have a vacuum. Let's get some of that stuff.
Yeah. Okay, so I've been saying this for a bit, but I don't want to go too much farther. And I want to be careful about, because Yvonne's going to not be very happy if we push it a little too hard, because she knows best about what can happen with the tether. So it is quite interesting how this stuff seems to be really accumulated down here. So we made it to 100 meters, folks. So we are now at 100 meters. So that sounds like a pretty good time to turn around. And it's getting to about 321 as well, so we'll...
Do we get a sense, like, if you sort of look
up... there's a fish, yeah.
Oh, yeah, there you go. Oh, yeah. Well, so those ones seem to not like the light so much.
Yeah, that one didn't like the light so much, yeah.
Is there can you give a sense of, like, what the slope is here like?
Yeah, for sure, yeah. I will be able to tell you that really soon. So the slope right here, I think, is it's about 30 degrees.
Wow.
35 degrees.
That's impressive.
So now we're going to make our way. Now we're going to start to make our way back, and we'll see what we see on the way back.
Tether feels fine so far.
Has this so question in the chat, has this rock formation ever been above the water? I think the best question right now is that we don't actually know, but I think that several of the folks that we've talked to who have an interest in archaeology think that it might have been. So in that time period where a lot of the ice sheet in North America went, way far down, even well past the Great Lakes, with a lot of that water locked up in ice, there is a possibility that some of these regions may have actually poked up above that ice and could have easily been sort of occupied by folks traveling one way or the other and that sort of thing. So I know that one of the things that Parks Canada in particularly is very keen to get out here and take a look for is some kind of evidence of any kind of archaeological remains that might show an indication of these regions having been once sort of exposed and out of the water prior to the melting of those glaciers and the formation of that giant Lake Agassiz that sort of our Great Lakes are now the remnant of. That's a great question.
But yeah, you can see the cliffs here are pretty impressive. So we've been just kind of going down this canyon. I'm almost looking straight up here.
Yeah, that's nuts. And it's basically at the bottom of that sudden face where we see a lot of that accumulation of stuff, right?
Yeah, that makes sense. Yeah.
Wild. Oh, it's so cool. Yeah, like as in, so sorry, there was a question in the chat about the benthic snow, like in terms of like, what is it? If we have, well, so I guess it depends on so the question was, do we get benthic snow? And I would have to follow that up with, I guess it depends on what we're talking about. In really productive systems, and we used to see it a lot on Lake Erie, you would get these whiting events where, because that has such high phosphorus, it would precipitate, there'd be periods of time where you'd have a lot of algal production and it would precipitate calcium out of the water, making it look white. The nutrient levels here in Lake Superior are too low to support that sort of thing. But what we are seeing on the ROV is there's certainly a lot of deposition of biological material around these shoals, which is one of the things that we're hypothesizing, right? These big, sudden structures in the middle of these open water environments that are surrounded by really complex currents should act as depositional zones for material either in the water column or stuff that's growing on those shoals. And just visually and anecdotally, that what we're seeing today seems to confirm some of that idea. What we'll really need to do, and this is something for probably for future missions, is to be able to get down there and actually sample some of this material, get a good look at sort of what it looks like using chemical tracers, and understand how well that matches those same kinds of tracers.
Okay, we got a couple of fish. We got a group of fish here up in front of us, and I'm just trying to see. I turned off my lights so that
we won't bug
we
them.
wouldn't bug them as
one.
much. And I'm trying to we're just trying to see what type of fish they are here.
Look at that.
Yeah.
Those big fins.
Yeah, and they're definitely using the mountain environment, and that's one of the things we've seen in a couple of the other dives, is that we've seen the fish using their big fins, and the redfin type lake trout in particular, morph, have these gigantic fins that are just incredible to see, and you can we are seeing them using these currents that form around these mountainous environments to basically just stay totally in one spot with expending almost zero energy, which is super cool.
And also to use those fins to sort of disturb some of that those algal mats to bring organisms up to feed on as well, which is pretty exciting to see that kind of behavior.
Yeah, that's right.
Yeah, here we go.
Yeah, a curious fellow there.
Beautiful markings on those fish, eh?
Yeah.
So,
how long? The question is, how long is the expedition, and are we just focusing on fish?
Gotcha. So we are. This is a 9-day expedition, but it takes a full 25 hours to get from our port to Superior Shoals. So we're actually only on site for 7 days, which is still a good chunk of time. We're able to collect a lot of information here beyond just fish. So we've got several sites that we've been sampling all week. We're collecting water for nutrient analysis. We're collecting zooplankton both night and day to try and understand what the zooplankton communities look like. We are collecting benthic invertebrates using Ponar to try and understand what those communities look like. For all of that material, we're also splitting the samples both into those that we can identify for what the community looks like, but also for chemical tracers to understand how the food web is kind of put together. And then there's the ROV and the fish aspects, which are being examined through hydroacoustics, through the ROV work that we're doing with Zach and Yvonne, and through some sort of more traditional capture, actually catch the fish, hold it in your hands, take some tissues, and put the fish back in the lake.
So what you mean to say is you haven't slept since we left?
We're doing our best to. I mean, so because we're in this sort of very isolated region, and it's so rare to be able to spend like a dedicated amount of time out here, the trick has been to collect absolutely as much information as possible in the short amount of time we're here, so that we can learn as much as we possibly can. I think in an ideal world, some of our automated samplers that we have out, like those up-looking acoustics units, I would love to be able to leave those out for like a year and then come and pick them back up later. The trick is just getting the funding to be able to do that. So we were lucky enough to get the funding to come out for a 7-day survey this year, and so we're doing our best to get absolutely everything that we can. But we're in kind of getting all the people together and equipment together to do this work. It's really sort of built a network of people that I think are interested in this work as well, and so hopefully that will translate into future studies in this region as well, so that we can learn even more. But we're really excited to see what we're going to be able to discover just from the work that we've done over the past several days and through this mission.
Nope. So we've come back to our anchor here. So I think I want to make sure to go to the left side of that anchor to not get.
Where's your tether? Can you see your tether?
Caught.
Can you see your tether?
Yeah. I'll take a look around there. No, it not immediately there. But generally, it's best to go back the way that you
Sure.
came.
Yeah.
So
Yeah, it feels like you're a little bit under the boat right now, out the starboard side.
Yep. Yeah, so there's a question in the chat about whether or not these formations, like these shoals, play a role in speciation or sort of isolation. And that's a good question. So we definitely see these different morphologies of lake trout in these, and typically see them more often in these offshore environments, right, where we've got humpers and redfins and leans all together. I believe they are super important in generating the conditions that produce those different morphologies. Is that speciation? I think the answer right now is not necessarily.
We got our buddies coming
Yeah.
to. Oh, we got a couple fish here coming to
So
check us out as we. Oh, and this one does have pretty.
Wow, look at those fins. Yeah.
This one's fins are pretty big.
Yeah.
I wonder if I turn on the. No,
So-
he's not interested in me at all. He's just
Doing his own
See you
thing.
later, buddy.
Yeah.
Okay, we'll leave you be there.
There's definitely sort of the diversity of ecological conditions out here that are prime for fish to sort of specialize on certain areas, and that can lead to sort of genetic isolation by organisms that look similarly breeding with each other. So those conditions are prime, but keep in mind in evolutionary time, these environments are really like they were basically blocks of ice up until about 20,000 years ago, which is not a lot of time for evolution to act. So is it, ask me that question again, I won't be here, but if we were to ask that question again in like another 100,000, maybe another million years, then yeah, like the conditions are such that you can get sort of that isolation generating different species, but yeah, they're not currently different species. Those different morphs can interbreed with each other, and the work that I've seen on the genetics indicates that they're similar enough that you wouldn't make that designation, and that's why we're careful to call them different morphs or morphologies as opposed to different species.
So as we start to head back towards the boat here, Mike, maybe we can just talk a little bit about what, the ultimate, reason that you guys are spending so much time trying to understand these lake mounts. When Yvonne and I have been out on the Great Lakes, and visited other smaller lake mounts, they just have a lot more life on them. And our sense is that these are quite important to freshwater ecosystems, and maybe ultimately they should be more protected, like seamounts are in more and more in the oceans, recognized as these oases for freshwater life. I just was wondering on your kind of take on the ultimate mission, I guess, here, or ultimate goal.
Yeah, definitely. I mean, so there's just sort of the very esoteric, like why are things so diverse? Why are things so productive in these environments? And we're certainly interested in asking that question. But I think it's important to think about these environments as, potentially as feeder populations to other populations around the Great Lakes that might be impacted by humans and different stressors. And so, and as we're putting out things like acoustic receivers to monitor fish movement, and hopefully in future missions we can actually get out here and tag fish too, we can start to get a better indication of how much these fish really are moving around from one spot to the other. I mean, the one thing that I will say, having been involved in some fish movement ecology work on the Great Lakes already is that fish move a lot more than we used to think that they did, you know? And so like I think it would be totally reasonable to imagine that we get fish from this region showing up in other parts of the Great Lakes. Well, and particularly in terms of Lake Superior. And so if you have these areas that are very productive, they can act as important feeders for these other populations that, like, by providing new genetic material, by providing individuals to those stressed populations that can ultimately help them rebound when they're facing challenges for whatever reason. So I think it's important to think about the preservation of these ecosystems as, you know, as a potential sort of rescue or last bastion for other regions on the Great Lakes and in Lake Superior specifically.
Because we mostly left them alone.
Yeah, we had this everywhere else on the Great Lakes, the fisheries were hugely impacted. We had to do all the stocking to bring them back. Out here, that was never done, and they've done just fine, right? And so, you know, it seems to speak to the resilience of these very unique ecosystems. And yeah, without any intervention on our own of ours, they seem to be doing just fine. So,
all right, so we're coming up to the propeller on the blue heron here. Got the light rays sort of shining through the water here.
I'm here for you, Zach.
Okay, and Yvonne is here for me more ways than one. So yeah, there's everything looks ship shape on the old blue heron there as we come up to. Okay,
Cut.
And okay, so Yvonne has caught it,
right,
and I have turned off the motors.
Oops.
And we are watching the robot come up to the deck.
all right, back on deck, no snags.
No snags,
No
all very
snags.
good, yeah. I think we'll just wrap it up.
Perfect.
Okay, we got the thumbs up from Yvonne. We're on the deck, so, well, thanks so much for joining us on this adventure. And we'd like to thank you to our partners at Canadian Geographic, Science North, and Parks Canada. And thanks to the amazing crew here on the Blue Heron, without whom we could not have done this. And this is just the beginning of what will be a series of live stream dives around the Great Lakes as part of the production of our new wildlife series, Hidden Below the Freshwater World. Subscribe to this channel if you'd like to see more. For now, we're signing off from Superior Shoal, but we'll be heading right back out there again to explore more of this incredible freshwater world. We'll let you know what we find. See you soon.